Very interesting. So they're building this thing still. It's
Yeah,
not.
I mean they're building it now, and they, it's got delayed a little bit, but I think 2020. Maybe 2024, 2025. Like it's happening quickly at the moment. There's a lot of effort going into it. So where Bristol's preparing one of the things for it now, which is the timing system, to make sure that every part of the detector are synchronized.
Oh wow. Okay.
So that's like a Bristol deliverable. So yeah.
And so is that your main thing now? Like kind of, because I think the thing is, so I remember with the CERN thing, you guys were gonna make the collider bigger or something like that, or you were talking about that, and I don't know,
Well,
did
that's
that even?
something I think. Yeah, it's going to be made bigger, not bigger, but we're going to get much more data from the High-Luminosity LHC, which will start in 2025.
High luminosity, what's that?
So that's it's the upgrade that we're doing. We're doing bits of it now, but we're doing most of it during the next long shutdown in 3 or 4 years.
Okay.
And we're going to prepare for the LHC to upgrade to send us 10 times the amount of data that they can at the moment per day. So
That's crazy.
we're going to get even more data, but the detectors all have to be upgraded.
I see.
Because they can't handle that type of radiation. They need to be changed, because they're already 10 years old or more.
Yeah.
So that's what we're doing at the moment, is trying to prepare for that upgrade. So that will provide a huge data set, like a massive data set, 10 times more what we had than we're getting now. And then we'll be able to, then we'll basically be able to look at these rare kind of decays in more detail. We'll be able to have more data to look for things like dark matter, particles that maybe we can't see at the moment because they're too rare.
Yeah.
So that's a really big thing as well. So those are the two big things in the UK and the US, I think, in terms of particle physics. It's the High-Lumi LHC and DUNE.
Yeah.
And both of them are, yeah.
Is it something where like that AI is going to be implemented quite a lot to kind of get the bits and pieces out? Has that kind of helped like the advancements in AI and stuff with how you process the data?
Yeah, for sure, because we're trying to use AI and machine learning to use it in terms of event selection, like trying to distinguish background events from signal events. Training neural networks to identify the differences, and then we can apply that to our data and see where we go. And the hope is, and that this is superior to the kind of standard algorithms we've been using up to now, where we think about the cuts we want and the requirements, whereas using machine learning, it can learn exactly the intricacies between what a signal event and a background event look like. So that's a powerful tool that we're bringing in now, and we're going to be using them in our triggers to kind of identify the events, so we keep the correct events, to analyze. And we can also use them in analysis afterwards to process data, to look at trying to extract the most signal from our data, basically the most useful information. So that's a big part of it, the AI now. It wasn't so much, I think, earlier on, but now it's like most of us are using it to kind of decide, how to do our analysis, basically.
Yeah. So I want to think. So in terms of like the precision, I guess how accurate you are with these things, you said like you're going to get 10 times more data,
Yeah.
how much more accurate do you feel like you'll be with the CERN thing, and then I guess maybe Dune? How much accuracy or much more accurate do you feel like you're gonna get? Is it even about accuracy? Is it like, do you think you're gonna find completely new things, or is it kind of just
Yeah. I think the idea with High-Luminosity LHC is to find new things. Like that's the goal. The goal is that we haven't quite got enough data to see things at the moment, and we will have it with High-Luminosity LHC. But it is also about accuracy, because if you have such large uncertainties on measurements, there's a limited amount of information you can extract from it if your error is so big. So reducing our errors on these things is also really important, because that's what goes back into the theoretical models.
yeah
If we can measure particle decays rates, to really, 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 really precisely, then we can put this back into our standard model, and then see exactly where there are things that don't quite fit into it. Like things that don't quite agree with our measurements, and that's where it becomes interesting, because then we know where to go and research, because we can see kind of little things that don't quite add up anymore. So it's a combination of looking for new things and getting increased precision.